All right, chapter 15, plane geometry. Let's go ahead and turn our page. Okay, so without using a protractor, estimate whether the angles are 30, 60, 120, or 150 degrees. So if we recognize that this would be 90 degrees, if we are halfway, we are 45. If we go another 45, we are 135. And then we'd go all the way to 180. We can say, hey, you know, we look like we're basically between our 180 and our 135, and we can say that's about 150 degrees based off of our view. So approximating it. Same story looking at this, realizing that if we have a right angle, half of it's 45, and that looks like we are less than half. So we could say, you know, we are probably a little bit closer than 30 degrees. Okay. So here we're told the outside diameter of an electrical conduit has 2.5 inches, and the conduit is 1/8 inch thick. What is the inside diameter of the conduit? So conduit, you've got pipe, and we're told our outside diameter here to here, that is 2.5 inches outside diameter. And then in here, we're told from here to here, it is 1/8 of an inch thick, which means on this other side it's also 1/8. And our remaining diameter, the inside diameter, is going to be 2.5 minus 1/8 minus 1/8. So on our calculator we can type in 2 fraction 1 fraction 2 minus 1 fraction 8 minus 1 fraction 8. And we are left with 2.25 inches. Okay, we've got Henry. He is going to install some lights around a circular pond. So we're told that, so you've got your circular pond, you got your lights, and you're installing them, and we're calculating our spaces around there, that we can't be any more than 5 feet 6 inches apart. Our pond has a diameter of 12 feet. And so we can take our circumference and we can divide it by the spacing here. So if we take our circumference, we're going to say that our circumference is equal to 2 times pi times the radius, which is equal to the diameter times pi. And so we've got 12 times our pi, and we can say 3.14 for our pi value. So 12 times 3.14, and we get a total of, for our circumference, 37.68. And that's feet. Now we're going to take that 37.68 feet and we're going to divide it by 5 feet 6 inches, or 5.5 feet. So if we divide it by 5.5, we come up with a value of 6.8509, and so on. So we can fit 6 whole sets of these. So we need at least 6. Okay, we've got a switch plate cover, so like a light switch cover. We're told that we're 4 3/16 tall or high, and we're 2 5/16 wide. And a rectangle is removed from a middle, and it is a 1/2 inch wide by 1 inch. So what we're going to do is we're going to calculate the area of the big rectangle and subtract the small rectangle from it. So we're going to do 2 5/16 times our 4 3/16, and we're going to subtract our 1/2 times our 1. So if we do 2 fraction 5 fraction 16 times 4 fraction 3 fraction 16, and we subtract 1/2 times 1. And we get 9 47/256. And if we convert that to a decimal, that is equivalent to 9.18359,375, and that is inches squared. Okay, number 6. All right, we've got a square surface cover. So we're 12.5 by 12.5, perfectly square. You've got a circular knockout, and these are centimeters, by the way. And this has a diameter of 1.23 centimeters. We want to find the area. So we're going to find the area of the rectangle, and we're going to subtract the area of a circle from it. So the area of the rectangle is 12.5 times 12.5. And we're going to subtract so if this is our diameter, 1.23, then if we take the radius, that's 1.23 divided by 2, we can take pi, which is 3.14, times the radius squared, 1.23 over 2 squared. Oh, we have a typo. 12.5, not 1.25. It's 12.5 times 12.5 minus 3.14 times 1.23 divided by 2 squared. There we go. Now that's looking right. So go back here. So our correct answer is 155.062375, and this should be centimeters squared. Okay. All right, this asks us, what is the vertex of ROP? So normally in this, you can look at the middle term, and O is going to be, or angle O is our vertex. Alternately here, you can see where this makes our angle, it's that hinge point. So the vertex is point O. All right. Okay, what is the name of the ray which lies on point P? So we're looking for the ray that goes this way, and it goes from O to P, so we draw the ray that way, or you can label it P, O, and just realize it starts from O, goes past P. And that would be our labeling. Okay, solve for x and y. Realize these two angles form a straight line, so if we take 40 plus y, it should equal 180. And if we subtract 40, we get y equals 140. And then here, if we add these two, y plus x equals 180. We can plug in 140 for y plus x equals 180, and subtract 140. So we get x equals 40. On this problem, it's the same one, they just want the y value. So in this case, we had y equals 140. Realizing that these two angles, where they're across from each other, we call them vertical angles, and you can use the shortcut to solve those. Okay, so if we have angle ABD, measure of angle ABD plus 71 degrees is going to equal 90, because we've got a right angle symbol there. If we subtract 71, we can take 90 minus 71, and we get 19. Degrees. So here we want the measure of angle MNP. The whole thing adds to 180 plus 180 equals 42 plus measure of angle MNP. If we subtract 42, 180 minus 42, we come up with the measure of angle MNP equals 138 degrees. Okay, vertical angles here and here, so we can say x equals 74. Supplementary angles, meaning they add up to 180, so 180 equals 74 plus y, subtract 74. Y equals 180 minus 74. We get 106. Okay, with triangles, if you add up all three angles, they add up to 180 degrees. So if we say that angle A, its measure, plus 91 degrees plus 45 degrees, they all add up to 180. We can subtract 91, we can subtract 45, and our measure of angle A is going to be equal to 180 minus 91 minus 45, and we get 44 degrees. For this one, find the measure of our missing angle. So we've got measure of angle D plus our angle E, which is 90, plus our 28 degrees, which is angle F, equals 180. We can subtract 90 and 28, and our measure of angle D equals 180 minus 90 minus 28, and we get 62 degrees. Okay. Once again, they add up to 180. And we've got 140 plus 20 plus measure of angle I. So we can subtract 140 and we can subtract 20. And we are left with 180 minus 140 minus 20. And we're left with 20 degrees equals our measure of angle I. Okay, perimeter. Realize that if these are, it's a rectangle with or a square with right angles, we can say that this is 5 meters and this is 5 meters. And the perimeter is measuring the outside. So we can take 5 plus 5 plus 5 plus 5, or 5 times 4, and get 20 meters. And so the perimeter is the amount of fence you buy to go around that shape. All right, for this problem, our perimeter, we are going to add up all these edge lengths. So 5 plus 3 plus 2 plus 2 plus 2 plus 3 plus 1 plus 4. And so I've got 5, 3, 2, 2, 2, 3, 1, 4. We add these up. Well, that's 8. And those 3 add up to 6. And these add up to another 8. And 8 plus 6 plus 8. That is 14 plus 8. And we get 22. Alternatively, on our calculator, we can take 5 plus 3 plus 2 plus 2 plus 2 plus 3 plus 1 plus 4. And we get 22. All right, next problem. Our perimeter here, because these are congruent, we can say that that is 40 centimeters as well. So if we have 40 plus 16, that's our grand total. 40 plus 16 gets us 96 centimeters. So congruency markers, there's 5 inches there. We're going to take 14 plus 8 plus 5 plus 5. And we get 32 inches. Okay. On this one, we are finding the area. If they look like a right angle, assume they're a right angle. So we can use our regular length times width measurements. So 4 times 12 is going to be our area. That gets us 48. And feet times feet gives us not millimeters, but feet squared. Okay, find the areas. So 9 times 9 gets us 81, and our units are feet squared. For parallelograms, so notice that these are assumed to be parallel. This gives us our vertical height on that. And parallelograms, you just multiply this vertical height times the overall width. So 9 times 8 gets us 72, and yards squared. Okay, another parallelogram. We just need this value and this value. We'll take 3 times 4, and that gets us 12 meters squared. Okay. On this one, we want to find the diameter. So realize that if we have a circle, if we measure from here out, that's our radius. If we measure all the way across, that is our diameter, which is also a radius plus a radius, or 2 times the radius. When we want to calculate the measure around the outside of a circle, we call that the circumference, and that is equal to 2 times pi times the radius. And if we want the area of a circle, that is pi times the radius squared. So we're going to use those basic equations to work off of it. So our diameter here equals 2 times our radius, in this case 9, which gives us 18 inches. Okay, here we want to find the radius, so remember that our radius equals our diameter divided by 2. And so we can get 7.2 divided by 2. and we get 3.6. And our units are centimeters. Okay, here we want to find the area. So first we're going to find the radius, which is the diameter divided by 2, which is going to give us 3 yards. And then we're going to find the area. So the area of a circle is pi times the radius squared, which is going to be 3.14 times 3 yards squared. So 3.14 times 3 squared gets us to 28.26. And this is yards squared. All right, if our circumference is 3.9, that means that the circumference equals 2 times pi times the radius. We can divide by 2 pi, and our radius equals 3.9 divided by 2 times 3.14, and we'll get 0.62 nearest tenth, so we'll say that's 0.6 centimeters. Okay, on this one we have the area. They want us to find radius. So if our area is 15 inches squared, that equals pi times the radius squared. We can divide both sides by pi. And our radius is going to be equal to the square root of the 50 squared divided by pi. And our units are going to be in just regular inches at this point. So if we take second square root 50 squared divided by pi, 3.14, we get our radius equals 28.2166, and we are going to the nearest tenth, so 28.2. Okay. Circumference is 60 millimeters, and we want to find the diameter. So remember that our circumference is equal to 2 times pi times the radius. We could rearrange that as 2 times radius times pi, and this is the diameter, so that is the same as the diameter times pi is our circumference. So we can say that 60 equals our diameter times pi divided by pi, and we get our diameter equals 60 divided by 3.14. We get 19.1082, and we're rounding to the nearest tenth, so 19.1. Okay, we've got circumference, we want to find radius, so remembering that our circumference equals 2 times pi times our radius, we'll divide by 2 pi, and our radius equals 27 divided by 2 times 3.14, and we get 4.2993. We're rounding to that decimal place, so 4.3 for our answer. And our units in meters. Okay, if we have a radius, we want to find the area of a circle. So our area of a circle is equal to pi times the radius squared. So that's going to be 3.14 times 8 squared. And we'll get 200.96. Okay, that is the end of chapter 15.